Hi everyone, welcome to our video lesson about the laws of exponents. So what we've done in the past is giving you guys a foldable or giving you guys a sheet that has all these laws on it. On Google Classroom in your packet you will find this same paper. These are just the rules for operations with exponents. So let's go through each of these and just talk about what they do. So the first law that we have is the product of powers. The word powers is the same thing as saying exponent. So what's happening between these two, highlight, what operation is happening between those two is multiplication. That's why you see the word product here. So the A's are called the bases. So these numbers, these are my bases. And then the numbers that are at the top, these are my exponents. I'm just going to abbreviate it with EXP. So whenever your bases are the same and you multiply them together, what happens is you add the exponents together. Okay? Our next property is called the quotient of powers. Quotient means that the operation is division. So whenever I divide like bases, I'm going to subtract their exponents. We've got a power of a quotient. So quotient means that I'm dividing something and I'm raising that division to an exponent. What happens here is you can essentially take the exponent and make it an exponent on the top and the bottom of your fraction. That's why you see a to the m and b to the m. Next, we've got a zero power. That is just saying that the exponent that's on your base is 0. Any number to the 0 power is 1. It's not 0, it's 1. We've got power of a power. That means that I have a base that has 2 exponents. You're going to end up multiplying those exponents together. We've got power of a product. That means I'm multiplying 2 things together. And that exponent can be distributed to both of the terms being multiplied together in the parentheses. We've got negative exponents. That means that whatever exponent that's on your base is a negative number. What we do here is we flip them. So I'm going to, this is the same thing as a to the negative m over 1. I flipped it and I made the exponent a positive number. Whenever you're dealing with negative exponents, we always like to change them into this 1 over a to the m form. It's the same thing if you have right here, you see you have them being divided. I flipped the top and the bottom of the fraction and I made the exponents positive. A rational exponent, you guys have actually already done this. Whenever you have a exponent that's a fraction, the m, the top number, is going to go inside the radical, and then the n, the bottom number, is going to go outside the radical. So that's rewriting it from a rational form to a radical form. So I would recommend, as you're going through your assignment on this one, that you just have this rule page open. I'm going to go ahead and do some examples with actual numbers now. Okay, so let's do some examples. So our learning target today is that we can use properties of exponents to simplify expressions. Just to kind of give you a reminder, the big number that has the exponent attached to it, so this number here, that is your base. The little number that's at the top, that is your exponent. Okay, so our first section, we're going to be using the product of powers, and you see that we have the formula there. So all of these have bases being multiplied, so I'm going to be adding those exponents together. It's crooked. Okay. So on the first one, the base is 5, and I'm multiplying those together. So this is going to become 5 to the 2 plus 6, because I'm multiplying those like bases. I add the exponents. So this is going to be 5, 6 plus 2 is 8. It's going to be 5 to the 8th power. Next, we've got three bases being multiplied together. They're the same base. I'm going to add the exponents. This little guy here, he has an exponent of a 1. It's not written, but whenever it's not written, it's implied to be 1. So this is going to be y to the 4 plus 3 plus 1. So this is the same thing as y to the 8th power. Okay, now let's look at this next kind of, it's a different way of writing it. There's no symbol in between these two, but they're still being multiplied together. So if you see no symbol, that means multiplication. What you're going to do here is multiply the coefficients together. A coefficient is just the number in front of a letter. And then you're going to multiply the letters together. So I'm kind of breaking this up into two separate pieces. So 7 times 6 is going to give me 42. And then y to the 5th times y, again, remember that has a 1 on it. So this is y to the 5 plus 1. So this is going to be 42 y to the 6th power. Okay, our last one on this section, I'm going to break it up into different pieces. So I'm going to group the numbers or the coefficients together. So I've got -3 times 5. I'm going to group my x's together. So I have x squared times, this guy is really x to the 1st power. And then I've got y to the 7th times y to the 6th power. Okay, so let's take it piece by piece. -3 times 5 is -15. X squared times x to the 1st power is x to the 2 plus 1. And then we're going to have y to the 7 plus 6. So when I simplify this, I've got -15 x to the 3rd power, y to the 13th power. And that is my fully simplified answer. Now let's look at the quotient of powers. So quotient of powers means that I am going to be subtracting the exponents. So when you're dividing like bases, you subtract the exponents. So let's look at our first example. Here you've got y to the 6th, You've got y to the 6th power divided by y. This y on the bottom has an exponent of a 1. So this is going to be y to the 6 minus 1, which is y to the 5th power. Next, we've got the same base of 6, and I'm going to subtract the exponent. So I've got 6 to the 13 minus 2, which is going to be 6 to the 11th power. Okay, now I'm going to break this up into a couple different sections. So I'm going to group the numbers together, I'm going to group the A's together, and the B's together. So I'm going to do 10 divided by 15 first. Then the A's grouped together, remember you're subtracting those exponents. So this is going to be A to the 7 minus 5. Then I'm going to have B to the 9 minus 9. So if I reduce 10 over 15, the biggest thing I can take from both of those is a 5. If I do 10 divided by 5, I get 2. And if I do 15 divided by 5, I get 3. Keep the A base the same. 7 minus 5 gives me 2. And then B to the 9 minus 9, 9 minus 9 is 0. The other piece of this that I can simplify is the B to the 0 power. Any number to the 0 power is 1. So this whole thing is just going to change into a 1. If I multiply something by 1, nothing's going to change, so I really don't even need to put that 1 there. This is going to be my fully simplified answer. Now let's look at the 0 exponent. So this property says that any number to the 0 power is 1. Let's investigate why that happens. So if I say 8 squared over 8 squared, if I try to use my quotient of power rule like I did on the last example, this would be base 8, and then I'm going to subtract the exponents because this is quotient of powers. So 8 to the 2 minus 2 is 8 to the 0 power. Any number to the 0 power is 1. You could also think of this as, let's expand these out. So 8 squared is 8 times 8, which is 64. 64 divided by 64, well, 64 goes into 64 one time, or you could think of this as canceling out to give you 1. So whenever you've got something divided by itself, it gives you 1, or you can think of it using laws of exponents, and it also gives you 1. So whenever you see that 0 exponent, your answer is always going to be 1, no matter what's inside the parentheses. So we've got negative 3x plus 7 to the 0 power. All that I care about is that I have a 0 on the outside of my parentheses. So this entire thing is going to simplify down to 1. Notice on the next example, you don't have any parentheses. You have 2 separate statements here. So the 8 in the front, I'm going to bring that down. X to the 0 power, any number to the 0 power is 1. So I'm going to replace x to the 0 with 1. I'm going to bring down the plus 5. Okay, so let's simplify. 8 times 1 is 8 plus 5. 8 plus 5 gives me 13. So my answer here is 13. My answer over here was 1. So make sure you're paying attention to those parentheses. Okay, let's look at negative exponents. So a negative exponent, we don't like to keep those in our answers. Those are kind of ugly numbers. So anytime you see a negative exponent, you are going to flip it. So remember, I can write this over 1. I'm going to flip the top and the bottom, and I'm going to make the exponent positive. So let's try this example here. So the bases are the same. They're both b. Using quotient of powers, since I'm dividing like bases, I'm going to subtract the exponents. So I've got b to the 2 minus 5 is the same thing as b to the negative 3. But we do not like when we have a negative exponent. I'm going to write this over 1. If I want to use this rule to make it positive, I'm going to flip the top and the bottom. So that's going to become 1 over b to the positive 3. And that's how we want to write it instead of leaving it with a negative exponent. Let's try some more examples. So on the next one, we've got 2 to the negative 3rd power. I'm going to rewrite this as 2 to the negative 3 over 1. Now I'm going to flip. So I'm going to have 1 over 2 to the 3rd power. 2 to the 3rd power is an easy number to evaluate. That's 2 times 2 times 2, 3 times. So that's going to give us 1 over 8. On the next one, we've got negative 3 raised to the negative 3. So this means that I'm really, this is still over 1. So I'm going to flip it. I'm going to have 1 over negative 3 to the positive 3rd power. So I still kept the parentheses there. So that means that that negative sign is attached to every 3. So this is 1 over negative 3 times negative 3 times negative 3. So if I multiply 3 negatives together, it comes back as a negative. If you multiply 2 negatives together, it comes back as a positive. But in this case, since I have 3 negative signs, I have an odd number of negative signs, it's going to come back negative. 3 times 3 is 9, times 3 again is 27. So this would be 1 over negative 27, or you can say the whole fraction is negative. Either one of these answers is fine. Okay, now we're looking at power of a power. So that means that you have something in parentheses that has an exponent, and then on the outside you also have an exponent. The rule with that is that you're going to be multiplying those exponents together. So for the first one, your base is x, and you're going to multiply the 2 and the 8. So this is going to be x to the 16th power. Okay, on the next one, this is a base of y. I'm going to multiply the negative 3 times the negative 4 on the outside. Negative 3 times negative 4 is a positive 12. Now let's take a look at the power of a product. So that means that you have 2 things in parentheses that are being multiplied together, and you're going to kind of distribute that exponent that's there onto each of the things being multiplied together. So let's look at this one. Okay, so this 3, the exponent that's on the outside, is going to be distributed as an exponent to everything that's there. So this is 4 to the 3rd power, x cubed. Be careful, you have an exponent here and an exponent on the outside. That means I'm going to be multiplying those two things together. I've got y to the 3rd power, and I've got z to the 3rd power. So let's simplify. 4 to the 3rd power is 4 times 4 times 4. X to the 3 times 3 is x to the 9th. And then y to the 3rd and z to the 3rd can't be simplified, so they're going to stay as is. 4 times 4 is 16. Times 4 again is going to give us 64. And I'm just going to bring down all of the other letters. Okay, and that's my answer. Let's try another one. So we've got 7 to the xy to the negative 2, and all that's being raised to the negative 2. So this negative 2 is going to get applied to every term that's in here. So this is going to be 7 to the negative 2, x to the negative 2. Be careful on the y. You've got a negative 2 already there, and I'm going to multiply in the negative 2 that's on the outside of parentheses. So 7 to the negative 2. Remember, we don't like negative exponents, so I'm going to flip it and make it positive. So this is going to be 1 over 7 squared. I'm going to do the same thing with the x to the negative 2. It's going to be 1 over x squared. When I go to evaluate y to the negative 2 times negative 2, those two negatives at the top are going to multiply to a positive 4. So I don't need to flip that one because it reduces to a positive exponent. Okay, now we can simplify. So 1 over 7 squared. 7 squared is 49. 7 times 7. Then I've got 1 over x squared, and I've got y to the 4th power. So if I write this as one fraction, the y to the 4th is going to be on the top, and then the 49x squared is all going to be on the bottom. So this is what you should get as your fully simplified answer. Okay, next one. Same thing. I'm going to distribute that negative 2 into each of our pieces. So you're going to have 6 to the negative 2, x to the negative 6 times negative 2, y to the negative 7 times negative 2, and z to the 0 times negative 2. Okay, so 6 to the negative 2. Remember, I don't like negative exponents, so I'm going to flip this as 1 over 6 squared. X to the negative 6 times negative 2. Negative 6 times negative 2 is going to give me a positive 12. Y to the negative 7 times negative 2. Negative 7 times negative 2 gives me positive 14. Z to the 0 times negative 2. 0 times any number is 0. So this is going to be z to the 0. Let's simplify now. So 1 over 6 squared is 1 over 36. The other ones can't be simplified. Z to the 0 power. Remember that any number to the 0 power is 1. So I'm just going to swap out that z to the 0 for 1. And I really don't even need it because multiplying by 1 doesn't do anything anyway. So my answer, I'm going to have the x to the 12th and the y to the 14th on the top of the fraction. And then I'm going to have 36 on the bottom. So that should be your fully simplified answer. Okay, let's look at power of a quotient. So that means that what's inside your parentheses is being divided. That exponent is going to be applied to the top and the bottom of your fraction. Let's look at this one. So this is going to be 3 to the 2nd power over 5 to the 2nd power. 3 squared is 9, and 5 squared is 25. If you can reduce that fraction, you should. In this case, I can't reduce it, so I'm just going to leave this as my final answer. Okay, next one. So I'm going to write this out a little bit easier for you to see. So this 2 is getting distributed to all these places. So I have 2 squared a to the 5 times 2, all of that over b to the 7 times 2. Okay, on the top you really don't need the parentheses. I can erase those. Okay, so 2 squared gives me 4. A to the 5 times 2 is a to the 10th power. And then b to the 7 times 2 is b to the 14th power. Since your bases are different, you have an a and a b, they are not going to be further simplified at all. I'm just going to leave my answer as is. Okay, this one is similar to the last one that we did. So this gets distributed to everything. So I'm going to have 3 to the 3rd power, a to the negative 4 times 3, over b to the 7 times 3. So 3 to the 3rd is 3 times 3 times 3, which is 27. A to the negative 4 times 3 is a to the negative 12. And then b to the 7 times 3 is b to the 21. So this is not my final answer because notice here, you've got that negative 12. We do not want any negative exponents. So I'm going to flip my fraction and I'm going to make it positive. So let's rewrite this fraction as 27 over b to the 21st times a to the negative 12 over 1. So all I've done is just broken my fraction into 2 separate pieces. What I'm going to do is flip this second piece of the fraction. So this is going to be 27b over b to the 21 times 1 over a to the positive 12. So the a to the positive 12 is going to be on the bottom of your fraction now. So your final answer looks like this. Or from the top, really all you're doing is just moving the a to the negative 12 to the bottom and making that negative exponent a positive number. So this is what you have. Okay, on this one, I'm going to distribute that negative 6 to everything. So I've got a times negative 2 times negative 6, b to the negative 5 times negative 6, over c to the negative 11 times negative 6. We're just going to simplify. So negative 2 times negative 6 is positive 12. Negative 5 times negative 6 is positive 30. On the bottom, negative 11 times negative 6 is positive 66. This problem doesn't have any negative exponents. All of my bases are different. They're a, b, and c. So there's no further simplification I can do. So you're just going to leave your answer like this. That concludes our video lesson over laws of exponents. Make sure that you're on the lookout for your assignment. Y'all have a great day.